Okay, I don't know what happened right now. Oh my god, hold on. Graph this absolute value function. Okay, I have y equals -2 absolute value of x minus 2 minus 4. First thing that I'm going to do is I'm going to write the formula for the absolute value function. The function is y equals a absolute value of x minus h close absolute value plus k. The reason I did this is because I want to compare, or I want to find out what's the value of a, which is in this case it's always, the value of a is always whatever's in front of the absolute value. For our problem, the a is equal to -2. The h is whatever's inside the absolute value with the x, and it will always be the opposite sign of whatever you have in there. Opposite sign. Okay? So, my h, I have x minus 2, right? I have x minus 2, therefore my h is positive 2. The k is whatever's after the absolute value. The k is whatever's after the absolute value. In my case, I have a -4 or a -4, so there you go. The reason I'm doing this is because the a can give me a lot of information, and from the h and the k, I can get the vertex, which is going to be, well, let's erase that too. The general form for the vertex is h comma k. In our case is 2 comma -4. Okay, so let me graph it. So the first thing that I do is I plot that vertex. So I'm going to go over here to the original graph that I have here on the right. So let me grab that, let me put it over here, and I'm moving everything. There we go. Let me see if I can hold this over here and this over here. There we go. I'm trying to maximize it a little bit. It's not too clear, but let's still use that graph. So let's do the graph in blue. Alright, so my vertex, let's plot that vertex, 2, -4. I go over here, 2 in x, I'm sorry, it's going to be, I'm going to go 2 in x, and then -4 in y, which I'm going down, -1, 2, 3, 4. So right here will be my dot, my vertex, 2, -4, right here. So that's going to be my vertex. Because of the a is negative, then if the a is negative, then my graph will open down. Okay, and then I do the absolute value of a. I do the absolute value of a to see if my graph is going to be narrow or wide. Absolute value of -2 is equal to 2, which is greater than 1, therefore my graph is narrow. Okay, so I have an idea what's going on with my graph. Now, my vertex, I have it here, and I know it's going to open down, and I don't think that was a good idea. So I have I know my graph is going to be narrow, then it's going to open down, and I have my vertex. Okay, I have my vertex. I'm going to go to the next page so I can graph it because I don't have space right now. -4. My vertex is to -4, and I have my graph. Okay, so it's going to be more clear, I guess. So my first step is to find the vertex. My second step is to plot it. So I'm going to go and plot it with, let's do red. So I go 2 and -4, right? 2, -4, I said you go 2 in x and then -4 in y, and that's your vertex. Okay, so vertex is 2 comma -4. Through your vertex, you draw a vertical line that is called the axis of symmetry. Axis of symmetry. Okay, that means your graph on the right side of that axis, on this side, your graph is going to be the same as on this side. Okay, there's symmetry among this line. Now, me, general, I like to make a table of values on one side. Okay, in this case, I'm going to make a table of values on the left side. And those values will be right next to the axis of symmetry. So if the axis of symmetry goes through 2, then my values will be 1 and 0. Okay, and maybe -1 if I can fit it. We'll find out. So again, I'm going to find 1 in my table of values. I'm going to do 0 on my table of values and maybe -1. And with them we'll do symmetry to the other side. So let's plug it in. So I don't know what happened there, but let's see, we'll find out. So I'm going to plug those values. I'm going to plug the 1, the 0, and hopefully the -1 instead of the x. Okay, so my first value will be replacing, instead of the x, I'll replace the x by 1, and I'll fill everything else. Okay, whenever you have something like this, you solve the inside of the absolute value first. So I have y equals -2. 1 minus 2 will give you -1 minus 4. Okay, I solved 1 minus 2. That will give me -1. That's inside the absolute value. That's my next step. I need to solve the absolute value, so I have y equals -2. Now absolute value of -1 turns into 1 without absolute value. Whatever's inside the absolute value will turn positive, alright? But not the previous step, right here. Once you have only one value, you do the absolute value and it turns into 1, positive. Now I do PEMDAS, and y is going to give me -2 times 1 is -2 minus 4. It'll give me -6. So my first point is 1, -6. Okay, let me plot it right away. I come over here 1 and I go down -6. So that will be my point. We're doing red, 1, -6. Okay, now let's do the same for 0. Now I'm not going to do every single step, but now this is going to turn into 0, and 0 minus 2 is going to give me absolute value -2. I'm going to do it here on the top. Now once you do the absolute value of -2, that turns into +2. So you'll have y equals -2 times 2 minus 4. PEMDAS will give me -2 times 2 is -4 minus 4 is -8. So I'll come over here and I put -8 right there. Okay, I'll do the same with -1. -1. Now it'll give me okay, it doesn't let me erase. So if I replace the x by -1, it'll give me -3 on the inside. If I replace -1 here, then it'll give me -2, -3. Absolute value of -3 is +3 times -2 is -6, minus 4 is -10. I kind of did mental math right there, but you know the previous two, so it's the same process. Let's plot those values, and that'll be 0, -8. 0, -8. So 0, -8 in y, so my point will be here. And the last one is -1, -10. This is the one, the -1, -10. So let's say whatever is going to be that thing. I go -1 in x and -10 in y. So right here will be the point. So I come over here. Now I'm kind of a crooked thing, but that should be a straight line. So it should be you always, when you graph an absolute value, you start from your vertex, okay, and you will go towards the points. Now I do symmetry to the other side, which is my last step. So this value is one step away from the axis of symmetry. Alright, this is one step. So I go from my axis of symmetry to the other side, one step, and at the same height, I put my symmetrical value right there. Same thing over here. This is 2 steps away from the axis again. 2 steps away from the axis. So the axis, I go to the other side, 1 and 2 steps. Okay, 2 steps. And the same thing over here. I go 1, 2, 3 steps away. And I start from the vertex, and that should be the absolute value. Again, it's a V shape opening down, and that should be your graph for absolute value functions. Okay, thank you very much. Have a good one.